Hey guys, today we are starting chapter 4. So we're going to look at 4.1, which is the graphs of the sine and the cosine function. So first of all, we need to talk about how all of our trig functions when we're talking in radians are what we call periodic functions. So a periodic function is a function f such that f of x is equal to f of x plus np for every real number x in the domain of f, every integer n, and some positive real number p. So kind of what that means is that these are going to have what we call a period, and then after that certain period, so that certain domain has passed, it's going to repeat the same pattern. So every periodic function cycles through the periods over and over and over again, and that creates kind of what this wave pattern looks like for our sine and cosine functions. So first we're going to look at our sine function. And so excuse me, kind of what we're talking about here is we've got that x part, we've got that n part, and then our p, our period, is the 2 pi. So that's what it says right here. Its period is 2 pi. So what that means is our period is going to start here at 0, and then it's going to go over here to 2 pi. And then after that, it's going to cycle back through and start the wave over, repeat the process. So it just cycles through the periods and keeps making that wave shape. So I've got a table over here so you can kind of see what some of those points are. We're taking all of those points from our unit circle and we're putting them here on a graph. So instead of it making a circle in the xy coordinate plane, now we're making just all of the x values go across and the y values go up and down. Our domain is going to be from negative infinity to infinity because we're not just going from 0 to 2 pi like our circle would. We're going to go past that. And our range is going to go from -1 to 1 because if we were talking about our unit circle, it had a radius of 1. So we were going either in the positive or the negative direction. And so we're going to keep that same idea. We're just changing it from being that circular function to making it a periodic function where our x's are going out instead of our like our degree or our radian measures or our x values going out instead of what we had for our xy sine cosine points. So the graph is continuous over its entire domain. That's what it says down here, right here. The graph is continuous over its entire domain. The x-intercepts are of the form in pi. So if you look, every single time we touch the x-axis, we've got 0, pi, 2 pi, or negative pi, negative 2 pi. I already talked about how its period is 2 pi. And then the graph is symmetric with respect to the origin. So what that means is that it is an odd function. And for all x in the domain, sine of negative x is equal to negative sine of x. That also means it has rotational symmetry. Odd functions have rotational symmetry. So like I was saying, we're taking our unit circle, and instead of like our x and our y being our cosine and our sine, now our x values are our angle measures, and our y values are just our sine values. Now, if we look here, we've got our cosine graph. Similar thing. We're taking our unit circle, but instead of our x and our y being our cosine and our sine, our x are our angle measures, and our y values are our cosine values. So same idea as what we were talking about with the periodic functions being x plus np. We've got our x, just like we did up here. We've got our n, and we've got our period, our p. So just like the sine, our cosine has a period of 2 pi. It has some very similar characteristics. The biggest thing you'll notice is that our sine function does start at the point 0, 0, because the sine of 0 is 0, while you'll notice that our cosine function starts at the point 0, 1, because the cosine of 0 is 1. It does have the same period, so we start here at 0, and we go to 2 pi before it starts the wave over again. And so it's got the same domain, negative infinity to positive infinity, the same range, -1 to 1. That's kind of coming from our unit circle again, having that radius of 1. It's also continuous over its entire domain. This time our x-intercepts are a little bit different. This time our x-intercepts are the form 2n plus 1 times pi over 2. So you can see our x-intercepts are at pi over 2, 3 pi over 2, negative pi over 2, negative 3 pi over 2. So our intercepts are all of the over 2 parts with our pi's, pi over 2, 3 pi over 2, 5 pi over 2. So it'll be the odd numbers times pi over 2, 1, 3, 5, 7, that kind of thing. So that's the 2n plus 1 is an odd number. The graph is symmetric with respect to the, it's not supposed to say origin, it's supposed to say axis this time instead of the origin. So the function is this time instead of odd, an even function. And for all x in the domain, the cosine of negative x is just equal to the same cosine of positive x. So it does switch up a little bit there. So let's talk about some other characteristics that can also happen with our graphs. The first one we're going to talk about here is what we call the amplitude. The amplitude of our graph is simply talking about how far up or how far down our wave goes. So if you noticed, our original graphs had a range from -1 to +1. So the amplitude there would be 1. It can either go up to +1 or down to -1. Your amplitude can change, however, if you have something that you're multiplying in front of your sine or cosine. So the amplitude is the absolute value of whatever that number is. So if you look here, we have in blue the graph y equals 2 sine of x. And in the red dotted line, we have our parent function y equals the sine of x. And so you can kind of see how the amplitude changes the height of the wave. Instead of going up to 1 and down to -1, that blue one is going up to 2 and down to -2. It makes it kind of a taller wave. So our x values don't change when we have a different amplitude, unless there's, another thing that's changing. But the amplitude itself doesn't change the x values. It changes the y values, the height of the wave. So if I'm trying to fill in this table right here, I would still say that at 0, we have sine of x is 0, and 2 sine of x is also 0. At pi over 2, the sine of x is 1, but now the 2 sine of x is up at 2. When I come here at pi, the sine of pi is 0, and 2 sine of pi is also still 0. When I come over here to 3 pi over 2, the sine of 3 pi over 2 is -1, but 2 sine of 3 pi over 2 is -2. And completing out that period, when I come to 2 pi, the sine of 2 pi is 0, and 2 times the sine of 2 pi is also 0. So when we're talking about the amplitude, it's going to change the height of the wave. Okay, another thing that can change our wave is our period. Now we've kind of already talked about the period. Our normal period is from 0 to 2 pi, but now if we multiply it by something inside of our sine, so sine of bx, or inside of our cosine, cosine of bx, that is going to change the length, the period of the wave. Change the length of the wave. So the amplitude is talking about the height, the period is talking about the length. And your period is found by using this formula, 2 pi over b. So 2 pi over whatever you're multiplying by inside of that sine or inside of that cosine. So if you look, once again, we have graphed in the red dotted line our y equals sine of x, our normal parent function. But now in our blue, we have y equals 2 sine, or sorry, not 2 sine of x. Now we're switching from 2 sine of x to sine of 2x. So it's going to change how the length of the wave looks. And so you can kind of see what I'm talking about there. Like kind of looks like, a slinky being stretched out or pushed in, is probably the best way to explain it, um, in my mind, like visually. So for our normal sine of x, I'm going to look at that one first with my pinkish reddish color that kind of matches the graph. We have our point at 0, 0. Then up here at pi over 2, it hits 1. So notice I'm kind of skipping over that pi over 4. I'm going to skip over the 3 pi over 4 too, because we come back down to 0 at pi. At 3 pi over 2, we go down to -1. And at 2 pi, we come back to 0. Now I skipped over those points, but I'm going to use them when I look at my sine of 2x, because I've taken my graph, my wave, and I've kind of squeezed it in. I've pushed it in. So I've taken the period and I've made it shorter. So instead of it going from 0 to 2 pi to make a full period like it does for our pink dotted or red dotted graph, now we're still starting at 0 here, but to go up, down, and back to 0, it only takes us until pi to make that full period. So I'm still starting with that first 0, 0 point, but now when I hit up at 1, that's at that pi over 4, halfway between 0 and pi over 2, because pi over 2 is where I go back to 0. Then halfway in between pi over 2 and pi is when I hit down at -1, so that's 3 pi over 4, because at pi is where I finish out my period and get back to 0. So I've taken it and kind of squished it in and made the wave length different. So that's how our period can change. And so you can see that because I had a 2 right here, if I use this formula, my 2 pi over b, well, my b is 2, so 2 pi over 2 means that now my period is just pi, which is where we ended. So my period is just pi. So that's how we can find our period there. Let's look at another one with the period, because that one is kind of a little bit trickier to get through. So here I'm going to look at this. It says graph y equals cosine of 2/3 x over 1 period. And it also asks what is the amplitude. So the amplitude, remember, is if we have something we're multiplying in front of our sine or cosine. So if I'm looking for my amplitude, you can see that I'm not multiplying by anything in front. So that means my amplitude is still just 1. So I'm going to go up to 1 and down to -1. My period is what's going to be a bit different because I am multiplying by something here. So remember, to find the period, that's my b value. So I'm going to do 2 pi over b, or 2 pi over 2/3. Okay, I don't really want a fraction within a fraction, so I am going to change this using my keep change flip. It's going to be 2 pi times 3 over 2, which is going to give me 6 pi over 2, or 3 pi. So my period now is 3 pi. So that's going to be the end over here. I'm going to go from 0 to 3 pi. So I know that I'm going to start at 0 and I'm going to end at 3 pi. But notice I still have 3 different spots I need to fill in my table to kind of get my other points. Because if we're looking at our cosine graph, this one right here, we're going to start at 1, hit at 0, hit at -1, 0, and back up to 1. So I can fill in those y values down here. 1, 0, -1, 0, back up to 1. But I need to figure out the x values for that 0, -1, 0 part. So what I'm going to look at here is that this one right here that I've labeled as the 2, this needs to be the halfway point. So what I'm going to look at here is I'm going to take my 3 pi and I'm going to cut it in half. Another way that you can look at it is I need to do half of my period. half of 3 pi is 3 pi over 2. So that's going to be my x value that goes with that. Now, if that one is half, to find my other points here, to find this one and this one, the 1 and the 3, those are going to be the fourths. This one is going to be 1/4, and this one is going to be 3/4. So I'm going to take that and multiply it by my period. So 1/4 times 3 pi is 3 pi over 4, and 3/4 times 3 pi is going to be 9 pi over 4. So 3 pi over 4 and 9 pi over 4. And so that's how I can figure out all of my x values, is whatever my period is, cut it in half and cut it in fourth and 3/4. So now that I have all of that, let's actually kind of put it on our graph now. So I know I've got 0. I'm just going to kind of evenly space it because we're just sketching it. So I know this is like my 3 pi over 2. This is my 3 pi. I'm going to say this one is my 3 pi over 4. This one is my 9 pi over 4. And then remember, we said our amplitude was 1. That means I'm going to go up to a positive 1 and down to a negative 1. Now remember, the cosine graph does start up at 1, whereas the sine graph starts at the origin, 0, 0. So 1, 0, negative 1, 0, 1. And then I'm going to do my best. Ooh, that was not my best. My best to kind of draw the wave in. And it just said to sketch it over 1 period, so that's all that I need to do. Sometimes it might say sketch it over 2 periods or sketch it over 3 periods or something like that. So just make sure you're paying attention to how many periods it wants you to sketch. So to kind of help you out, I've got a list here of guidelines for sketching graphs of sine and cosine functions, some steps really. Figure out what the period is, divide it into the 4 equal parts, so that's the 1/4, 1/2, 3/4. Okay, evaluate the function for each of those 5 values. So remember, you start at 0, then the 1/4, 1/2, 3/4 in the whole period. That's the 5 different parts. 1, 2, 3, 4, 5. Plot the points that you got there and join them with the sinusoidal curve. Sinusoidal is just a fancy way of saying the wave. And then draw the graph over additional periods as needed. So if it says over 2 periods, draw another one. If it says over 3 periods, draw 2 more ones. So go that way. So what we're going to do is we're just going to get some more practice. Got a couple more that we're going to do. And then the last thing we're going to do is actually look at a graph and see if we can go backwards and get the equation. So wrong thing. Let's do another one. Ooh, in this one, I added in one more thing that can change our graph. Forgot that I added this in. You can have a reflection, just like we can have a reflection in any of our other parent functions that we talked about in college algebra. If you have a negative in front of your graph, so when that a value is negative, it's going to reflect across the x-axis. So I've got a negative here, which means it's going to reflect. So that would be like the very last thing that I would deal with. I'm going to figure out all of these other steps that I set up here, 1, 2, 3, 4, 5, and then deal with the reflection. So my first step was to find the period. My period, remember, comes from that B. So that would be from this 3 right here. So remember, it's 2 pi over B. So in this case, 2 pi over 3. And there's not anything else I can do to simplify that, so my period is 2 pi over 3. So that does mean that I'm going to go from 0 to 2 pi over 3. So if I wanted to make a table, it didn't give me one this time, because remember, it's not always going to give you one. I'm going to start at 0. I'm going to have one empty spot, another empty spot, and another empty spot. And then I would fill the last spot with my 2 pi over 3. Okay, to find that middle one, I got to take half of my period, so 1/2 times 2 pi over 3. That's going to give me 2 pi over, well, 2 times 3 is 6, and I can simplify that to just pi over 3. So this is going to be pi over 3. And then I got to get my fourths. So I'm going to do 1/4 times the 2 pi over 3. That gets me 2 pi over, well, 4 times 3 is 12, which is going to simplify to pi over 6. And 3/4 times 2 pi over 3. 3 times 2 is going to give me 6 pi over 4 times 3 is 12. And that's going to simplify to pi over 2. So I've got all my x values now. Then the next thing says evaluate the function for each of the 5 x values from step 2. That's where my amplitude and that reflection are going to come in. So it does ask over here, what is the amplitude? Well, the amplitude comes from this 2, but we do have a reflection, so that is going to adjust everything in a minute. Then I also have to pay attention to what function I'm actually looking at, the sine versus the cosine, because that's going to tell me if my first y value is a 0 or if my first y value is a 1. Because remember, sine starts at, it would help if I had the pen, 0, 0. Cosine starts at 0, 1. 0, 0, 0, 1. Sine is 0, 0, cosine 0, 1. So my example 4 is a sine graph. So since that's a sine graph, that means that I'm going to start at the point 0, 0. I can put a 0 right here. Now remember, normally I would go 0, 1, 0, -1, 0. But we've got an amplitude of 2, and we've got a reflection. So instead of going up to 1, I'm going to have a negative for the reflection. And then since the amplitude is 2, it's going to be a -2. The 0 is still going to be 0. That -1 now is going to be positive because of the reflection, and 2 because the amplitude, and then that's still just going to be 0. So I've got everything I need. I'm going to graph it over one period. So let's put it on our graph. So I've got the point 0 right here. Pi over 6, pi over 3. Let me spread those out a little bit more. Pi over 6, pi over 3, pi over 2, pi over 3. So pi over 3 is the halfway point. The 2 pi over 3 is the full period. My fourths are the pi over 6 and the pi over 2. And then with our amplitude, we are going up to 2 and down to -2. So I'm going to start at that 0, go down to my -2, 0, up to 2, and back to 0. So wave shape. I'm not very good at drawing, so please don't judge my drawings here, but that's generally what it should look like. Hopefully you can draw a little better than I can. Okay, let's look at another one. Example 5. Graph y equals -3 cosine of pi x over one period. So same idea. I'm going to start by finding the period, start kind of filling in the table. Then I'll use my amplitude and anything else to help me get the y values and graph it. So make a table. I'm going to have x, y. I know start at 0. Have 3 blank spaces. And then I'm going to fill in my period. So remember, your period is 2 pi over b. Well, my b this time is pi. So I'm going to have 2 pi over pi, which means my period is just 2 because those pi's cancel out. And that's what my note says right here. When b is an integer multiple of pi, The x-intercepts of the graph are rational numbers. They're just going to be numbers without pi in them, which is going to make it a little bit, I don't want to say easier, but a little bit easier for us to figure out what all of our x values should be. So my period over here is going to be 2. So if I make my little chart that I've been doing, if I'm trying to figure out what's exactly in between that, well, 1/2 of 2 is just 1. Then if I get to my fourths, 1/4 of 2 is 2/4, which is 1/2. And 3/4 of 2 is 6/4, or 3/2. There's no more pi in my graph here. Now let's talk about amplitude. We've got a 3 right here, so my amplitude is going to be 3. So I'm going to go up 3 and down 3. I do have a negative, which means once again I'm going to reflect. And then since I'm a cosine, that's going to tell me where I'm going to start. So the cosine graph normally starts at the point 0, 1. So that means normally I would have 1, 0, -1, 0, 1. But I've got an amplitude and a reflection that's going to adjust that. So the amplitude being 3 and that reflection means I'm going to start down at -3. The zeros stay the same. I could go ahead and fill both of those in. So I'm going to start down at -3, 0, go up to +3, 0, and back down to -3. So I'm going to fill in my x values and draw my graph. So we start down at -3, 0, +3, 0, -3. Move in our curve like that, and that's what it should look like. Please don't judge my drawings, I'm sorry. Okay, and like I said, the last thing we're going to look at is we are going to look at a graph and see if we can go backwards and figure out the equation. So I'm going to zoom in a little bit. It says determine an equation of the form y equals a cosine bx or y equals a sine bx, where b is greater than 0 for the given graph. So we're going to need to figure out if it's a sine or a cosine first. Then we can start building our equation. So since we're starting down here and not at 0, that's pretty much a dead giveaway of which one it's going to be. Because remember, the cosine graph, just like this one, right, normally starts at 0, 1, where the sine graph normally starts at 0, 0. So if we're not starting at 0, 0, yes, we are starting down, but that's going to come from our amplitude and our reflection and everything. Since we're not starting at 0, 0, we know it's not a sine. So that's how I know that it's going to be a cosine graph, because I'm not starting here. If it was starting here, that's where I would have the sine graph. So I'm going to build like my basic y equals cosine of something. And then I'm going to try and fill stuff in. Okay, we did just talk about how we're starting down. So that means that it does have a reflection in it. So I can put a negative there because it's reflected. I am starting down at that -2. But I do know that my amplitude is 2. And I can fill that in right there. I also forgot to put my x in my equation. That'd be helpful too. So then the last thing I really need to figure out is what is my period? And that's going to fill in right here. So my wave goes till 4 pi. So remember, my 2 pi over b gives me my period, which is going to be that 4 pi. So I just have to solve that for b. I would start by getting b out of the denominator. So 2 pi is going to equal 4 pi b. And then I would divide both sides by 4 pi. You'll notice the pi's cancel. So I'm just looking at b is equal to 2 over 4, or b is equal to 1/2. my period is 1/2, and that's what's going to fill in the rest of my equation. And there we go. So my personal opinion, I think it's a little bit easier to go from the graphs to the equations than from the equations to drawing the graphs, but we did a little bit of both. Make sure you get started on your assignment that goes with this. It will have a mix of both of these on here to get you that extra practice. Let me know if you have any questions, and y'all have a good day.